Hello, welcome to Automation and Manufacturing. Our objectives today: give a brief history of automation, name a device that has revolutionized factory automation, list 5 reasons for employing automation, name at least 3 components of CIM, and explain what CAD and CAM are.
Throughout history of manufacturing, people have sought more efficient ways to make products. These efforts can be divided into 2 tasks: designing products for efficient manufacture and making products more efficiently. Although divided, these tasks are not independent. Often the work of one directly impacts the other. For example, Eli Whitney's work in producing muskets with interchangeable parts required design changes. Musket parts were designed so that all like parts were exactly alike, so they could be easily manufactured. These parts were made so that any like part would fit in any musket. This enabled the muskets to be assembled more efficiently. Thus, the first task impacted the second.
This interdependence must be addressed if a company is to compete in the world market. Key to this focus is automatic or automated manufacturing, which is often called automation. Automation is the application of control to an apparatus, a process, or a system by means of mechanical or electronic devices. Automation uses computer and automatic controls to replace direct human control.
Automation: replacement of human control to a machine, process, or system with control by mechanical or electronic devices.
Development of automated manufacturing. It is difficult to trace automated manufacturing to any specific event or invention. Ideas for automatic manufacturing machines have many roots. Early efforts to accomplish automation used strictly mechanical controls.
One of the earliest attempts in factory automation came around 1800. At the time, there was a growing need for blocks to raise and lower sails, move heavy cargo, and position cannons on ship. A typical warship at the age required over 14,000 blocks. At that time, each block was individually made by artisans working on lathes, drills, and other machines. In England, Henry Maudslay undertook the task to produce blocks using an automated production line. After 6 years of hard work, the world saw its first large-scale mass production manufacturing line.
However, mass production did not extend to other industries for over 50 years. Furthermore, its adoption was not in England, but in America. Such a movement marked by revolutionary changes in production is called an industrial revolution. This industrial revolution ushered the Western world into what became known as the Industrial Age.
Even earlier roots of factory automation trace back to mechanized toys. They were developed to entertain members of high society. One such toy, a wooden model of a pigeon, designed by architects of Tarentum, dates back to about 350 BC. Soon after 350 BC, Hero of Alexandria began to experiment with pneumatics and hydraulics. He developed a number of water-driven mechanisms, including automatic temple doors and signing mechanical birds.
His work applied to many machines, toys, music boxes, and musical clocks developed in Europe. During the 18th century, these devices had machines that used discs or discs that had ridges or holes in a problem detail operating instructions that guided the program code held on the disc caused the item to chim or move according to set plan.
The idea of programmed cards, or discs, was adapted in 1804 by the French loom maker J. M. Jacquard. His looms used a series of punch cards to program the machine to automatically produce a set pattern in fabrics and carpets. In 1822, Babbage proposed a building machine called the difference engine to automatically calculate mathematical tables. The difference engine was only partially completed when Babbage conceived the idea of another, more sophisticated machine called the analytical engine. Later, Herman Hollerith applied the principle to an automatic data recording and accounting machine using punched cards.
The invention was first used for the 1890 United States Census. It reduced the time needed to tabulate the results of the Kansas by 50%. His punched cards became the forerunner of the computer card, which was used to enter data in early computers.
In the 20th century, the idea of a punch tape program was tried on manufacturing machines. These machines, called numeral control machines, became the backbone for the Second Industrial Revolution, the Automation Age. The arrival of modern factory automation came with the recent development of the computer. This useful machine is the dominant feature of the computer revolution, which impacts our lives every day. Its advent brought us out of the automation age and moved us into the information age.
This period in history began in 1945 with the development of the first electronic computer. It was called the Electrical Numerical Integrator and Calculator. From this dramatic start came the mainframe computer, the mini-computer, and the microcomputer that operate today in almost every facet of the public and private community.
Components of an automated system. All efforts to automate manufacturing are guided by a few basic goals. These goals include reducing manufacturing costs, increasing product quality and consistency, enhancing manufacturing flexibility, improving marketability of products, and reducing the reaction time to changes in market demand. These goals have caused most manufacturing companies to adopt labor and material saving programs and systems. Examples of labor and material saving programs and systems: artificial intelligence, computer-aided design and computer-aided manufacturing, flexible manufacturing system, process automation, just-in-time, manufacturing resource planning, materials requirement planning, and basic machine controls. The complexity of the systems increases as they move upward the chart. The simplest are mechanical, numerical, and computer machine controls. These range from simple tracer lathes to complex computer-controlled machining centers. The most complex is artificial intelligence, in which computers are programmed to process data and make decisions. This is radical departure from the normal computer tasks of data processing. All the various components presented in Figure 34.5 are used to make up a package called Computer Integrated Manufacture. CIM is defined by the National Research Council as all activities from the recognition of a need for a product through the conception, design, and development of the product, and on through production, marketing, and support of the product use. All of these activities use written, numeric, or graphic data. This data is integrated into a single dynamic system. CIM is an ultimate goal of many manufacturing enterprises. It is only beginning to be implemented into manufacturing companies today. The two main components of CIM are computer-aided design and computer-aided manufacturing.
CAD is a computer-based system used for creating, modifying, and communicating a plan for a product design. Activities performed by CAD include: engineering design is the preparation and documentation of various product design ideas and solutions. Design analysis is the evaluation of product designs using computer-simulated tests such as for stress, heat transfer, and deflection. Design presentation is the preparation of engineering drawings that are used to communicate approved designs to manufacturing personnel.
Some references say CAD stands for Computer Aiding Drafting. Some say that CAD is strictly a drafting tool. They refer to a system that also has design and analyzing capabilities as computer aiding drafting and designing.
CAD, engineering design, design analysis, design presentation. CAM, computer process control, computer numerical control, robotic control, adaptive control, manufacturing support, production scheduling, inventory control, material requirement planning, and numerical control tapes.
More recent practice accepts CAD as standing for all drafting, design, and analyzing functions. CAM is the use of manufacturing operations. CAM operation is considered with one or both of the following. Computer process control. This is the process of using mechanical and electronic means, NC machines and robots, for example, to change the shape, size, or composition of materials. Manufacturing support. This is processing of data including things as machine status, parts counts, and processing variables.
CAM uses computer to assist in monitoring and controlling either or both components of manufacturing operations. Computer may be used to direct machines through a series of steps to process materials. Also, computers may gather and process data about the effectiveness of an operation.